Okay, so we wrote this down, and I'm pretty sure like a lot of this is like, what do you mean by rate? What is accumulation? Like a lot of maybe the vocabulary is like weird, right? Let's go ahead and talk about some of this. So here we go. Before you actually go into your groups and do this Desmos activity that I have planned for you, I first want you to process independently. So like think about it first on your own. Super important. So let me go ahead and talk about this entry problem. This entry problem is going to be the focus of our unit, and we will be using like sigma notation, what we learned last Thursday, later on in the unit to kind of incorporate and put together what we're learning. But for now, let me give you some examples on what is a rate graph and what is an accumulation graph. So here are the two separate samples. So right here we have a rate graph. Now it is a rate graph because, and let me just, sorry, somebody was coming on in. Okay, let me explain why this is right here on the left-hand side is a rate graph. Because look at the units here. This is the y-axis. The units right here for the y-axis are speed, miles per hour. Miles per hour is a rate. Do you all remember when we were talking about beats per minute, the heart rate, right? Like how doctors measure sometimes people's health. That's a rate. So is miles per hour, because you have miles per something. How you would write it is like this, like miles over a fraction per hour. So that's what makes this right here a rate graph. Over here, we have the accumulation graph. It's an accumulation graph because for the y-axis, you have something that's increasing. In this case, miles or distance is getting accumulated. So that's what makes this an accumulation graph. And that's what makes the one on the left-hand side a rate graph. What I have right below the graphs are the corresponding table. So you could kind of see the different patterns and how the numbers are being brought about. So let me just pause that. I didn't like that I covered the 50 that was there. Let me see if anyone has any clarifications on what is a rate graph versus what is an accumulation graph. I see question marks by Jose. Did you have a question? Let me know. Happy to kind of re-explain. So right now what I did is I defined to you a rate and accumulation graph, and here's the part that I'd like you to do independently now for the next 3 minutes. Here are the questions that you'll be answering in your group, but for now I want you to answer independently. Number 1, they're down here. How is the accumulation graph related to its corresponding rate graph? So in this case, how is this distance graph related to the rate graph? That's accumulation related to rate. And number 2, how does each graph verify the other? So those are the 2 questions that you want to think about right now in the next 3 minutes. So please copy this down and try to answer these 2 questions in the next 3 minutes. Let me check out the chat. No problem. Okay, cool. I thought there was like a super confusion happening. Okay, cool, y'all. So right now, let's do this on our own. Try to attempt to answer number 1 and number 2 as you're looking at these graphs, because we're going to be doing this together with groups on Desmos in a bit. All right, 3 minutes, we'll be back. Some of y'all had some time to go ahead and answer your initial thoughts about how is an accumulation graph related to its corresponding rate graph. So in this example, we have how is a distance graph related to its speed graph? And then how does each graph kind of verify the other? Like how does each one kind of like give you the other graph? So that's going to be the questions you'll be answering in your group today, but I first definitely want you to first do that on your own. Let me clear my screen. Okay, so let's go on to the next part, which is where we're gonna have our breakout groups, and it'll be about like 30 minutes or so. And I'm gonna walk you through in a bit what the Desmos looks like. So my look for's, by the way, is of course be on task. I'll be sending reminders, I'll be like sending 5 more minutes or something like that. My expectations when I pop into different groups would be I should see group sharing of the screen and also interactions. We should be completing the Desmos task fully. And when I come in, it's not to help, it's actually to observe, unless there's like technical issues that someone needs help with. The Desmos code is going to be on Google Classroom, and only one person in the group joins. We're not having every single person join. We're just having one person in your group that's joining for you, and also sharing the screen. So that's like the expectations of what's going to happen. This will be graded so that you.
So I'm the facilitator. Who wants to be the?
It don't matter.
Wait, what you say?
It don't matter.
Alright.
You will be the captain because I'm the recorder and somebody else already called timekeeper, so you will be team captain.
Awesome. And then this group, I heard y'all were discussing who's doing what. So whoever's the facilitator, if you could share the screen, if able to.
Yeah, just give me a moment right now.
Awesome, awesome.
In the rate graph, when the car has traveled 1 hour, how much distance did the car travel? How did you know you are correct using the rate graph or table? Explain.
Maria, are you the facilitator?
Yeah.
Awesome, awesome. So then, does anyone have any ideas about that first question in this group?
Doesn't the car go for 50 miles? Doesn't it go 50 miles in 1 hour?
Yeah, and then just go ahead and justify that. I think you're right. Was that Marjorie?
Yeah.
Yeah, I think you're right. Let's go. And I don't know who's typing that one now. Is that the same person, Maria, or?
Yeah, that's me.
Okay, perfect. Yeah, I think you're right, Marjorie. We just now as a group want to explain why. So you said in 1 hour it traveled 50 miles.
What information from the graph or the table helps you justify speed?
We can divide, right? The distance by the time.
150 divided by 3.
Because isn't distance divided by time equals velocity?
Yeah.
Right? Yeah.
Yeah, it's also like the slope too.
Should I add something more?
Yeah, just probably put like how distance over time equals velocity, I guess. Just so they know like what we mean by that.
I gotta stir my syrup.
The reason why is because the I can't type.
I'm gonna be real with y'all. I got my boobies out. Oh, I'm sorry. Wrong time. It's a good thing I have my camera off, Mr. Dono. I'm sorry. I'm just trying to keep the conversations live and everyone's spirits up.
Okay, that's okay. Thanks.
The reason why is because the graph is only at 50. Oh. For every hour. Is that what we said?
Exactly. But
it says they're all 50.
I'm not sure about this one. Either 50 or we have to problem solve for something else.
Sorry about that. I don't know because if you're still going, I don't know.
What did y'all say for number one?
We said it was 50 miles
Okay.
because on the table the time was 1 hour.
And because it goes 50 miles per hour, it must have gone for 50. Okay, that makes sense. So if it travels for 3 hours, how much distance did the car go? If you know for 1 hour it did 50 miles.
So then would you multiply it by 3 to get 150?
What do y'all think? So we had the idea of, do we multiply by 3? Who said that, by the way?
Me, Juliana.
Juliana. Okay, can you explain why you think we would multiply by 3?
Because it's okay. Because it says when the car has traveled for 3 hours, how much distance did the car travel? So I'm guessing it's not the same. And since for every time it's still going the same amount of speed, since it's 3 hours, you would multiply it by 3.
Yeah, that makes perfect sense. What does this group think? So like Lali, Jose.
I was gonna say 0, but I don't think it's 0.
Because like y'all said for 1 mile it traveled 50, right? 50 miles. And then it needs to, so for 3 hours, so it can't be 0 because y'all already agreed that 50, right? So then for the next 3 hours, it's still going at the same speed. And I think that's why Juliana multiplied by 3. But then you could also, Lali, explain why you think it's 0. That's a good idea out there that we could tackle.
Well, I was gonna say 0 because the miles per hour hasn't changed.
The miles per hour hasn't changed. Okay. And using miles per hour, this question is asking about total distance, right? Like using speed is trying to get from that, like how much distance did it go? The speed looks like it's the same, right? The speed hasn't changed. Speed is constant. But just because the speed is constant, does that mean it didn't travel any distance?
No.
It's still going 50 miles per hour.
Okay, so yeah, and then Jose in the chat put also no. Awesome. All right, I'm gonna jump into other groups. Interesting discussion y'all are having.
So do we all agree that it went 150 miles or not?
Yes.
Never mind. I see why.
Is it because it's just like, how do I say this? I don't even know.
Like it's because like we're like for this we're measuring just the speed. So every hour, like regardless of how many hours have passed, we're
Yeah,
always
it's not adding up, huh?
Yeah,
It's just saying, yeah, okay.
Yeah, but then for the distance, like they add up because it's like each hour you're traveling 50 miles, so you add that up.
She said breakout number 2 is on the last slide. Woo.
Okay. Do y'all want to add anything?
Doesn't this graph show that the speed isn't changing because it's just going straight and it's just like the distance increasing?
Yeah.
Because the question also asks, what information from the graph or table helps you justify speed?
So then how should I Explain it.
The car distance between 50 miles every hour. We know this because I'm not sure. Like, kind of just say that the speed doesn't increase, it stays the same, and that's why it like kind of goes upwards like that, and it doesn't go like for a curve or anything because it stays the same.
Okay.
Was just a recap of what we did. Now let's go into the synthesis. Well, actually, before the synthesis, I'd like to show you the reminder of our essential questions. And these were the ones that you were asked to answer in the Desmos as a group. It was number 1, how is the accumulation graph related to its corresponding rate graph? Number 2, how does each graph verify the other? So these were the 2 essential questions you were asked to kind of think about and to talk about with your group. And today we're gonna like have some time to get the answers to those, and you will also have some time to individually answer this on your own in our Google form. All right, y'all. So before we jump into our our synthesis of the Desmos activity, I'd like to show you this poster I really, really loved because it kind of, and I took this from, I don't know whose it was someone from this class, right? So I really liked it because it really kind of highlighted all of the big ideas. Now this one right here, we've kind of talked about when you multiply. For example, we did 50 times 3. This, when you multiply, you get your accumulation graph. So I like how they were like this, and they kind of did like a spiral or a circle or rotation. They said, well, if you do distance divided by, I don't know what the h represents, but they did division, right? If you divide here, you get your speed. Oops. I don't know if anyone wants to jump in there or if someone's unmuted. Let me just mute all for a second. Yeah, so I really love this graph because it kind of, you're answering kind of that second question where it says, how does each verify the other? And we kind of talked about like when you multiply or you find the area of this here rectangle, you get accumulation. Whereas when you divide the y over the x or distance over time, that gets you back to the speed. So for example, here, 150 divided by 3 is 50, which shows up here. And also this group is kind of circled and pointed that out in relation to their table. So that's just kind of like highlighting the posters you guys kind of made yesterday as well, pointing to like our big ideas. So I'm just kind of reminding y'all here, and I really, really like this poster of due to the circular nature and the way that they're kind of showing the answer to that second essential question. So let's go ahead and get this all in writing though. So this was nicely represented in this visual here, but let's go ahead and get the big ideas written down. So again, this is just here for your reference, but here are the big ideas, everyone. Let's please write this down. 1, the total area under a rate graph, that was that speed graph that was horizontal. The total area under a rate graph actually is approximating the total accumulation. Remember, that's distance in our example. Because remember, when you multiply the height of the rectangle and the base, you get the total distance. So that's a humongous big idea there. There we go. And let me go ahead and visually show you that as well for the visual learners among us. So what I mean by area under the rate graph, right now I'm just coloring it in here. And I'm coloring that the area, basically it's the square kind of formed from the line down to the x-axis. Just coloring this in. And maybe let me use a different color. Maybe I'll do text. So again, when you do the height, so in this case, it was 50, the height for this graph is 50 miles per hour, because that's our units on the y-axis, times the base, 3 hours, is equal to the total distance. And in this case, you all agreed on the Desmos that it was 150 miles. Just notice how that is the area of that yellow portion. It's basically the area of the rectangle. So that's that's a humongous big idea. The total area under the rate graph gives you the total accumulation. In this case, it gave us our total distance. So that's, make sure we write that down, and feel free to like as well draw this and visualize it for yourself as well. The next big idea. This is always going to be the case. It's huge. Whenever you have a rate times time, that gives you accumulated unit. That's always going to be true. And we're going to be taking a look at different rates. We're not only going to look at miles per hour, we're going to also have different examples of rates that we're going to take a look at. And another way to see the second bullet point right here is basically, let me go ahead and write it right here on the side. Let me change my color. So for example, let me rewrite the way I did the first part where it was miles per hour. I'm going to do this. So it's like, for example, we had 50 miles per hour. I'm writing it like that because that's like the formal fraction way. Because I'm going to show you that something cancels out when we do this. And we multiply by 3 hours. The reason why this gives us total accumulated unit, actually I'm going to rewrite that as the shorthand, hours. Because like that. There we go. Or maybe let me go ahead and post this to the chat if anybody knows. When I set this up like this, do you know what I could kind of cross out when I multiply these two? Maybe if anyone knows in the chat. Oh, okay. Juliana. Oh, and Henry. You both said hours. That is correct. Maybe y'all kind of remember that from like either it could have been from chemistry where you have like the units and you kind of cross off when hours is on top. It's basically like hours divided by hours is like 1, so they cancel out. So these two cancel out. And that's why we end up with 50 times 3 being 150 and our units being miles. So that's a humongous big idea there. And it connects with what we saw in our graphs. That's just an example for you. Let's see what's in the chat. Oh, we didn't have chemistry. Tough. Duh. It's okay, but you don't have to have chemistry in order to kind of like visually see this. And you have this graph right here so that you have that proof. That's all right if you didn't have chem. All right, so that was the second big idea. Now let's get to the third. So like I said, I really like that poster that one group did, right? Because it had that kind of like, it told us in the end how accumulation is also related to rate, right? And here's that last part. Some of you, when I was jumping into your group, some of you did say the word slope. So when you were doing distance divided by time, that's the change in y over the change in x. So what you were talking about was slope. The slope of the accumulation graph is the constant rate of the rate graph. So for example, and let me go ahead and color code this. Maybe I'll do red. So for example, this here, the slope of this line, it's going to do the rise over the run. So my rise, it's going up by 150 units, or 150 in this case miles. And our run is going to be 3 hours down here. And when you do 150 divided by 3, that's going to get you the 50 miles per hour. mph, shorthand. And again, that's why I liked that one graph, because it went like showing you that it goes back to here, and this goes to this, because when you multiply, you get this accumulation graph. So those are basically the big ideas from the Desmos activity. Let's make sure we get those down. I'm also going to pause here for a bit so you could get this down, and also for any questions that anyone might have. And again, what we did here is we answered the essential question a bit, but we're going to take a look at some more examples in a second. All right, so I'm going to go ahead and pause here for a minute, either for questions or for y'all to just finish getting this down. A few more seconds on this slide. And again, these are posted on Google Classroom, so you could go back. I could also send the recording. All right, I'm going to go ahead and clear this slide, and let's move on to some examples. And again, remember, y'all, we're going to have we're going to go ahead and have a Google form to fill out after this, and you want to make sure that in the Google form you relate back to our big ideas, so that I could understand like where you're at as far as understanding the concepts of this. All right, so here's some examples, y'all, of some more graphs. So when you're copying this down, just do a sketch. The important thing you need to get down is, first off, like which one's the rate, which is accumulation. When you do your axes, make sure that you put the units. So for example, this one's dollars per hour. See dollars/hour. This is hours. The accumulation graph here, we have dollars and we have total hours. So let me go ahead and talk about this. As y'all are kind of just doing a rough sketch of it. You don't have to do all the detailed lines or anything like that. So here's another example of other rate graphs with their corresponding accumulation graphs. This right here is a pay rate graph. So in this example, now I know it's hard to see because it's kind of like the line is going through like an in-between here. This is counting up by fives, but if you look at the table, it gives you more information. So basically, you're getting paid $13 an hour. So this horizontal line is intersecting at the y-axis at 13. So this is like that. So here's another example. Again, as you can see, the rate graph with the accumulation graph. Your pay rate is constant, usually, unless you get a pay raise, right? Usually your pay rate is going to be constant per hour. So that's why when you go down on the Y in the table, it doesn't change. You're still going to get $13 an hour. But the accumulation, how much dollars you get, should go up. So again, super essential to pay attention to what the units are. Notice that as the time goes up, so as your hours go up, your amount of dollars gets accumulated. And I'm trying to make a connection to that word accumulation graph. It's going up. In addition, notice that when you multiply these two numbers, you get the number right here. So for example, 1 times 13, 13. 2 times 13, 26. 3 times 13, 39, and so forth. That's because it connects to our big idea that the area under a rate graph gives you your accumulation. So let me give you a quick little, again, sketch of that as y'all are copying this down. Let me show you, like, for example, in the first, I'm gonna do it in the first 2 hours. We understand that in the first 2 hours, you should be getting 26 bucks if you're getting $13 an hour. But we wanna kind of prove it using our model, using our graph. So what I'm doing is I'm going ahead and I'm coloring in the area under the curve from 0 to 2. And it's kind of hard to see yellow, hold on. From 0 to 2. So the base of this here rectangle is going to be a base of 2. The length is 2. The height of this here rectangle, the height is basically how far up it goes on the y-axis, and it goes up 13 units. So the height is 13. Notice how the area of this rectangle, 13 times 2, gives us $26. It's $26 again because the units cancel. It's a little bit hard to show that here. So this is dollars per hour. I did a dollar sign. And this right here was hours. So again, if you were to multiply these two, you'll see that hours cancel out to give you 26. Similarly, this shows up in your accumulation graph because after 2 hours, if you trace your graph, you're gonna see that you're gonna hit $26. So it all kind of like connects. So this would be at $26. So I'm going to go ahead and pause here for any questions, and also for you to copy this down. Put about a minute on this. All right, y'all, that's our time there for this slide. Let me go ahead and clear this. We're gonna do one more example and then we're gonna have our Google form. So let me clear this up. One more example. And these aren't all the examples. We're gonna take a look at other types of rate graphs. This right here is just to build our understanding and to make connections to our big ideas. Here's our last example that we're gonna take a look at. Now, oh wait, I don't know, Miles. That's an interesting question. But okay, here's another example on the last one before we hit our Google form. So here is an example of hair growth rate versus its accumulation. So here, hair growth rate, we're making, I think this is more like made up. This is assuming that your hair grows about an inch per month. So this is inches of hair per month, and this is the amount of months. So again, always pay attention to the units. You know that something's a rate when it has that dash, it means division, and you say per in between it. Over here, you have the total inches of hair and then month. Now this is assuming someone has 0 hair at the beginning, and then they're starting to grow from 0. So in this here example, again, the growth rate down here is constant. So we're assuming that the growth hair rate is constant. So each month it grows an inch. So it's 1 inch per month. And over time, though, we know that hair gets accumulated. So over time, even though the rate is constant, your hair is still growing. So that's an important thing to differentiate between. All right, let's go ahead and make the connection to the big idea now. Now, the big idea says that the area under a rate graph gives me total accumulation. Let's try this out for the first 3 months. So again, I'm going to use yellow. So in the first 3 months, over here, 3, I'm going to just go ahead and shade the area under the curve. Notice when I do area under the rate graph, sorry, not curve, area under this line, notice that I stop at the x-axis. That's what we mean when we say area under the rate graph. Always stop where the x-axis is at. So you have like a rectangle. Next, we're going to go ahead and check and verify if this, big idea is true here. So the base of my here rectangle is 3 months. So I'm going to write 3 months. Maybe I'm going to shorthand it like this. This means months. Just do that. Our height, well, our height looks like it's always at a constant 1 inch per month. So my height right here of this rectangle is going to be 1 inch per month. So again, this is the base, it's 3 months, and my height is 1 inch per month. Again, let's do that multiplication to see whether the area of this rectangle will give us the accumulation of hair growth over the next 3 months. So we set this up, we go 3 months, base times height, 3 months, that's months. I know it looks really messy. 3 months times 1 inch per month. Month. Let me just add the S so it's the same. All right, so again, we're going to cancel out what's the same, top and bottom. So months will cancel out, and we're going to be left over with 3 times 1 inch. So 3 inches of total hair. I'm going to circle that. And then you verify it. So if you go to your accumulation graph after 3 months, you go up, trace up, 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 and you'll see that it's barely there, kind of gets cut off, but this right here is 3 inches of hair. So again, when you multiply or when you find the area, it gives you the accumulation graph. Let me also write that down. Area of the rectangle gives you total accumulation. Exclamation points. That's just a tremendous connection to our big idea there. So again, I'm going to pause 1 more minute, and then we're going to head into our Google form so that we could kind of process and do some problems like this on the Google form. But this is going to be independent on your own, so we can see where you're at. All right, everybody, I hope you all are ready for our exit ticket. To be honest, I'm very excited to see what your thoughts are, what your understandings are on this. So let's go ahead and jump into that. Well, let's see the chat. Okay, awesome. Someone said they took a screenshot. That's a great idea, to be honest, y'all, for our notes. It's a great idea, and you could take little notes on the side if you're doing digital notes. All right, y'all, so here we go. So we're gonna have about 10 minutes, noise level 0, time to do this Google form. Again, it's going to be asking you to make connections to the big ideas that I showed you on slide 39, but it's also in the Google form itself in case you, you know, or it should be in your notes as well, but let me go ahead and put this in there. And yes, this is unit 3. That's correct. We skipped. There we go. So somebody said in the exit ticket today, there we go. What happens if your rate or accumulation changes with a rapid decrease or increase? In other words, oops, what happens if it's not like a rectangle, right? It's not just a horizontal line. What if your rate is changing? If you think about the real world, we don't always walk at a constant rate. We don't always drive at a constant rate, right? We move at different rates. Like think of if you're driving in a car, you sometimes are going 30 miles an hour, sometimes 35, 33, you know, it's always changing. So the real world has changing rates, right? So I just really liked to bring that in because it leads us, whoever had that question, leads us into our next portion, which is, what if you have a rate graph that's curvy? I just call it curvy, but it's a rate that's changing. So if you look at here, in this here example, I'm gonna have us do a participation check in a second, but let's first take a look at this. So let me first read it and then I'll talk about it. So it looks like this following graph models somebody called Bristol's heart rate in beats per minute. So beats per minute, in your mind you should think that's a rate. Whenever you see the per, beats per minute, so it's a heart rate over time in minutes, okay? During the last 10 minutes of a yoga class. So then you verify, and then at the end, her resting heart rate is 70. So you confirm, yeah, so in the end, after the 10 minutes, it's 70. So it looks like her heart rate, 70 beats per minute. So it's a rate. So I'm gonna put beat per minute. Yeah, I'm failing at that, hold on. T per min. So her rate starts off at 70 beats per minute and it ends at 70 beats per minute. But because this person was doing yoga, the heart rate beat per minute, the rate increased, then it lowered and went back down over the course of 10 minutes. So we have an example here of a rate that is changing. And that's why I kind of titled this is, what if you have a rate graph that's curvy? What do we do then? So what I'm gonna ask you all as a class, not in the chat, I actually have something else for you to fill out. Just think about this for now. What are some ideas and what do we do? How do we find, like, how do we apply that big idea of area under a rate graph? So given a curvy graph, how do we find the accumulated unit? That's a big giant question. By the way, in your participation, let's say you don't have any ideas and you're stuck. That's totally fine. If you're stuck, I'd like you to just put a notice or wonder, totally fine. Let me show you how this participation is going to look like. So it's slightly different. And I'm doing this slightly different because I want to make sure that everybody's included, not just a few of us who are, you know, always participating and so forth. Let me just exit out of this. So for you, I have for period 1, I'm going to put this link into the chat. And then we're going to all open it together as I explain how we're going to do this participation check. So the link is in the chat. I'm going to click along with you. And also another reason why I'd like to kind of collect the ideas and or notices and wonderings in this is because I want to refer back to it. So what you're going to do is you're going to either put your name or initials. So let's say you don't want people to know who you are, just put your initials. I have everyone's roster, so I know your initials. I want you to put down how are ways we could tackle this problem. Any ideas you have, or if you don't have any ideas, put a notice or wonder. Go ahead and take a few minutes to write that in. And we have about 20 students in here, so we should have 20 of these rows filled out. Question: how would the accumulation graph look like, right? How would it? All right, heart rate spiked because he watched a scary movie. Maybe during yoga class, they might have watched a scary movie. I wonder if solving, if there's more than just multiplying and dividing. Right. Yeah, because this is curvy. So how are we going to multiply and divide like we did in our big idea? See if there's more down here. Whoops. All right. I wonder if you have to find two different rates. So a lot of wonders, good wonders here. Ooh, this one's a good question. I wonder if we could still use the same way of finding the accumulated unit with the curvy graph. That's a great question. Similar steps or different steps that we use for this type of graph? Someone put IDK. Make sure it's either a notice or wonder. So I want to push you more than just IDK. Try to notice or a wonder is totally fine with me. I love those people who use the black portion of the graph. Y'all are cool. All right, let's see. Let's see if anyone had any strategies. All right, I think we need to find the rate in a specific time. So kind of like, I wonder if you mean like chunking it up or something. Can use/make an equation to be able to find the total amount. Like maybe finding the rates and making it into an equation. Yeah, maybe an equation might be part of it. And then we could use the graph as a straight rate graph and then add additional slope to answer or figure it out. So kind of like thinking of it like a straight horizontal graph and then maybe adding in the curves later. That's a good idea. And then I wonder what we're looking for. Awesome, y'all. So these are great questions and or great ideas. Let me just make sure I didn't see anything different on here. All right, cool. So we're gonna definitely come back to this and we will figure out a way, like how would we determine this? It's actually gonna be the highlight of our unit. It's gonna be the main thing. Yeah, awesome. All right, so let's go ahead and jump into our closure. So I actually had a Padlet activity, but we don't have time for that, so we'll just do that next time. Let's jump into our check out, everybody. So great job on the participation. Let's go ahead and jump into what we're going to be doing today. So we're going to be going back into this here problem. And this is the questions right here on the left-hand side that you'll be investigating with your group today. So one of the questions that you definitely want to talk about when you hit your groups is what does the area under this curvy rate graph represent? So when I say area under the curvy rate graph, what I mean is, and let me, again, just for the sake of consistency, I'm going to use yellow. So area under here. So again, I'm just shading. I'm going from the curve down, stopping to the x-axis. I wish, and then it stops here at 10. So it goes like that. And we just, oops. Y'all know I'm trying to shade below this here curve as best as I can. So your goal in your groups is, first off, figure out what this yellow shaded area represents. That's the area under this here curve. Figure out like what in the world does this represent in this context? Because this is talking about Bristol and she's in yoga class and it's a graph representing her heart rate over minutes and time. So there's that shaded region. And number two is how do we approximate the area? So in your group, you're going to talk about like what can we do to approximate this here area? How do we approximate this yellow part that you see in our graph? And
yeah, now we have to figure out the area. So
right.
for the squares, it's base times height. What's the base? Base is in the bottom.
So wait.
Like it's not exactly on the thing.
Yeah,
But we
but
could
that's
do
why
it,
it's an estimate.
yeah, we
Estimate.
could do it. Yeah, mamas.
Well, yeah, Julio, we're not gonna be correct.
Oh, wait. Oh,
okay.
This would be so much easier if it was just a straight line.
Should we call her for help?
She's already in here.
Oh, really? Oh, damn, my bad. It's because I had the screen halfway. I didn't see. Okay, so we're kind of stuck. So
Okay.
so we figured out the bottom half, which was 700, and then we kind of we're using the formula for the semicircle, which is area equals pi times r squared, radius squared over 2. But we forgot to divide.
Okay, so you're almost there. I like that strategy. So all you have to do is take 25 pi and divide it by 2, right? And then you'll get your...
But when we do that, do we have to like multiply the pi, or do we leave the pi just there?
If you want to, yeah, I would recommend multiplying it. So just convert it to 3.14 and multiply it, then divide it by 2. That would give you a good like estimate, and then you could add that to your 700.
Okay, so we do 3.14 divided by 2.
No, times 5 times 25.
Oh, okay.
And then that will get you at 78.5. And then we add that to the 700.
Yeah, to get, because you want the total, right? Because you already had 700, and then there's your like semicircle approximation.
This is so much harder. Sedano, I give you props for doing this.
Yeah, it's hard. That's why I write, but in reality, I also write messy in real life too. So it's pretty the same for me.
That's why I'm color coding it.
Dior is times, not divide.
All right, I'll fix that. Thank you.
Awesome. Let me check in another groups. This is looking great, y'all.
Wait, and then after we do this, we're done?
Well, after you do that, you want to, as a group, try to figure out, well, what does that area mean? Like once you have 700 plus, you know, what you just get right now, what does that represent? Like, what does that area under this specific rate graph mean? And it's okay right now for it to be a guess, because I'm going to give the answer when we come back together.
Okay.
Awesome.
Thank you.
You're welcome.
Oh, Jesus, that was so
100. Yeah. Hey, my 2 looks really good. Humana, you should be doing this. You're the better drawer.
Girl, I don't know how to use mouse.
I
know how to use pen, but not a mouse.
And then 4 minutes. Is this is at 120? Okay, so right here was a consistent. I can type that in.
All right.
Hey, Mama.
Mama just left.
Could this be smaller? Yeah. Wait, what happened to my rate?
Why are you zooming out?
I'm a screenshot it.
Yeah, but you can barely see.
So these two groups did similar strategies. I think the answer this group got is 89. Let me know if that's correct, that that's what y'all got. This group got 980, and they specifically showed like each calculation there. Let me see the chat here. Oh, okay. And one group got uploaded to the first period Padlet. Oh, yeah. I think I noticed that. Okay, so if you're in that group, okay, but it's going on there, so it's okay. I could see it here. All right. This group, let me point out their strategy.
We added an extra ×2 for the black one on accident. So yeah, just it was. I think it would just be at 119.
Oh, 1,019 for this one.
No, I think it'll be 913 beats.
913 beats.
Yeah.
This black one is
Just
not.
119 because yeah.
Oh, I like the strategy. Did you all just divide half of this and then you at the
Yeah,
end?
because we knew that all the other color ones was like the same thing for the other side.
Okay, look at that strategy, everyone. So again, you're saying this will be about 9 something, right?
Yeah.
Okay, and then your group said that this area represented beats, so like total heartbeats. Awesome. Cool. That's an awesome strategy. I was like wondering why half of it was filled in, but now I get it. All right, and then we have this one. Oh yes, I definitely want to share this one, y'all. This is so cool because it's like the only group that did the area of a semicircle. So they did this bottom part like a giant rectangle, and they got 700. And then they used the formula for the area of a semicircle to get the remaining piece, and they got a total of 778.5. And that's okay because it's an estimate, and this is like kind of like they made this as an estimate as a semicircle. I really liked that. All right, let's see what else. So again, these two are similar. This one used like kind of like rectangles. This one here says that the area under the curve shows a difference in time and how there was an increase, constant, decrease in beats per minute. All right, they kind of recognize patterns here. I don't know if y'all did get an answer. I wonder if it's this right here. Is it 9 times 120? Let me know. But otherwise, we could kind of see how they divided up their area here. All right, so let's go ahead and talk about what does the area under this curve represent, and does represent the total beats Bristol's heart made. The reason for that is it relates to our big idea that the area under a rate graph represents accumulated unit. The accumulated unit in this case is heartbeats, and it's not per minute, it's just heartbeats, her total heartbeats. And the reasoning as to why, like why does it that this area represents total beats? It's because if you write down the big idea that we did, which is if you take the rate times time, you're going to see that the units cancel out. So let me write it here so I can make sense here. So remember, one of the big ideas is rate times time equals accumulated unit. That was a huge big idea. In our scenario, the rate is the beats per min. So I'm going to write that right here. So my rate is beats per min. And I know you all realize how hard it is to write beats per min. And I'm using it's not a mouse, it's the pad. And my time is in minutes, so I'm gonna put min. Kind of like the same thing, like as if you're doing a rectangle. It's like the height is your rate, the base is the time. When you set up this multiplication, remember from our big ideas, something cancels out. In this case, minutes are the same, so those cancel out. You're left over with beats. So that's why when you find the area under this curve, it represents total beats. So as an estimate though, some of you had like around 900 to like 1,000, right? That means her heart beat for these 10 minutes in that yoga class, Bristol's heart beat about 1,000 beats overall. So that's what it represents, the area under this here curve.